Good afternoon, everyone. I was hoping that we would have a microphone so that my voice can be elevated slightly, so that everyone is able to hear me properly as I make my submission. Do we not have one? Okay. Once again, good afternoon, everyone. Good afternoon to the residents in the City of Johannesburg, the province of Gauteng, and South Africa as a whole. I think it would also be important to also acknowledge the citizens in the rest of the world. As a result of what we have experienced, it has come to our attention that it's an incident that has sparked international interest. So it would be prudent for us to also acknowledge the fact that we have an audience from other parts of the world. I'd like to first acknowledge the head of administration, the city manager, Mr. Floyd Brink. I acknowledge all the directors present, acknowledge all the members of the media that are present, and say good afternoon to ladies and gentlemen. On the 19th of July, 2023, as the city, we experienced a devastating explosion to which we have been diligently working to respond and to recover. From the onset, our focus was to ensure the safety of our residents. In the immediate area of explosion, to secure the site of the explosion, and thereafter to recover services to the area. Our rapid response and emergency services were exceptional in their response and actions from the day of the explosion. They displayed great technical ability and preparedness to respond to emergencies and disasters across the board. As a city, we are grateful to the men and women who undertook this task and to who excellently delivered on. Our experts and team have expressed to us the manner in which we responded was in line with international standards and protocol. Although the incident itself was a difficult one, but we recognize and we applaud the services in the City of Johannesburg in the manner in which they conducted themselves and the manner in which they were able to respond. We are also humbled by the support received from the national government as well as the Gauteng provincial government. We must also thank the Johannesburg Chamber of Commerce and Industry and a variety of other private sector and emergency response services provided, who offered their skills, resources, and experience in response to the explosion and aftermath thereto. As the executive mayor, I established a technical task team led by the city manager to lead a detailed and advanced investigation into the explosion and the responses required from the city. This team has included highly experienced engineers, gas specialists, technologists, and academics who have worked tirelessly to ensure that we conduct a rigorous investigation into the possible cause of the explosion. The team has also been inundated with a number of inquiries from cities and engineers across the globe who follow closely on this incident. This is where international interest lies to understand the cause of the explosion and to build knowledge so as to be able to have a view on the causes of such explosions across the globe. This has placed us under pressure to ensure that the team that investigates is the best in the space, and that the outcomes of the investigations are credible and backed by science and evidence. Importantly, as the political leadership of the City of Johannesburg, we have also mandated the city manager and the technical team to provide us with assurance that such incidents will not occur in the future. The team is now fully engaged as part of our response to recover processes in diversing the means to test and monitor the presence of various gases that lie below the surface and in the tunnels underground. They will also provide us with plans to mitigate such incidents from occurring in the near future. The creation of a smart city as a priority of the current administration, and the mandate to the city manager and the team is that the rebuild and rehabilitation of Lillian Ngoyi Street must ensure that going forward, we set the standards for the management and underground infrastructure and the roads that lie on the surface. We've also had positive engagements with various affected stakeholders, including property owners along Lillian Ngoyi Street. Our intention is to ensure that as we push to rehabilitate and rebuild, we do so in a transparent and inclusive manner. We are grateful for the cooperation and partnership. Ladies and gentlemen, I wish to assure the residents that we are doing all in our power to ensure that we create a safe City of Johannesburg. I also wish to bring to the attention of the residents the deliberate action we took to manage this disaster and showcase our administrative and technical abilities. This was done through the establishment of the technical task team, and it was my intention to showcase to the residents that the city functions primarily through its administrative and technical capacity. In my State of the City address, I assured the residents that the seeming political instability in the city at the time should not be the cause of great concern, as our biggest asset. We have a functional and competent administration. In this city, the city manager and the technical task team have indeed displayed the best that Johannesburg has to provide. That the city is stable and is functional. The city manager will share the report that we have now received and some of the technical details emerging from the report. I would like to also further emphasize that through this ordeal, and hope, as a matter of fact, that our residents have witnessed the strength and the resilient nature of the city's collaborated efforts to dealing with challenges that emerge under any situation and or condition. As the current administration and the executive in the City of Johannesburg, we take pride in the fact that we endeavor to fill up the critical vacancies that are required for a rapid response. we endeavor to ensure that the human capital that the city identifies for critical roles within the administration are those of a quality that can inspire confidence in our residents and demonstrate the fact that politics play a critical role in providing a mandate, but the diligent execution of services that are required by our residents is done so by a stable and competent administration. And on behalf of the executive, we are proud to say that the city manager has demonstrated just that. But we continue to monitor him. He's not over the threshold as yet. We are still monitoring him. But let me hand over to you, CM, to assist us moving forward. Thank you.
No, thank you very much, Executive Mayor, members of the media, ladies and gentlemen. As indicated by the Executive Mayor, today we've received a report from our service provider undertaking the investigations into the cause of the gas explosion that occurred in Lillian and Ngoye Street, formerly known as Bree Street. The following professionals were added to the COJ team with specialist skills specifically for inspections and investigations. Fire specialists with experience in industrial explosions and gas systems, international fire dynamics and explosion simulation specialist engineer, specialist in explosion, gas and fire dynamics at universities and international network of fire engineers, structural engineers, geotechnical engineer, electrical engineer, civil engineer, forensic specialist, and occupational health and safety specialists that we brought in as well. And these were the teams that we have added, or for them to complement the team that we already have technically within the city. And it's important that the area that I'm now going into, because these were some of the questions that we were asked in the past few days or the past few weeks. The following were ruled out by the investigation, and I think we need to place emphasis on the work that has been done here. One, there were no terrorist action or zamazamas or cable theft or foul play by anybody at this particular point. That we could not detect. All emergency responses by our EMS, JMPD, and all departments from the city were effective, they were compliant, and there were no shortcomings that we had to address in that regard. We can also indicate at this point, based on what we have seen, that it was not an Igoli pipeline explosion or any pipe rupture, nor a large leak before the explosion. Only post-explosion, as confirmed on the timeline of the Igoli gas SCADA system. So what we have done in this regard, we sent in a team of independent specialists from our side as the city to go and monitor the systems of the Igoli as well, the SCADA system. They then went back into time to go and see what it was in terms of the volume and pressure on the system, and then compare that to at the time when the incident took place. At the time or just after the incident took place, I think at the time when there was a road collapsed, that was the time when some of the damage happened to one of those, where there was a pipe rupture on a 100-millimeter pipe. And that is what Johan and the team can also share with you. What we have further ruled out is that there were no negligence by electricity or any department or any intentional action by individuals or intentional release of gas into the tunnel. So that we could not detect. No signs of people living in the tunnels, no recent cable theft that we could find. What was the cause? And I think this is something that I've been asked for some few days now. What is the cause? What was the cause? The type of the gas that has fueled the explosion is methane. We can say it with certainty, it's methane. Now you would know that methane is lighter than air, so usually methane will then basically rise. It will then go up. It traveled up all along the service tunnel from an unknown source to the crest of the tunnel near the Van Brandes Street. Now the team will also indicate to you the speed at which it moved. It's anything between 350 to 1,700 meters per second. That is why if you had to look at the CCTV footage, you would have just seen it would have taken a second or two up until from the top part up to the part of Loveday, from Loveday to Van Brandes. The specialist will share a presentation which will give more details on the cause of the explosion. Now, there were always questions around why did we not see any fire? And they will also explain, if you look at the low explosive level, there's a threshold of between 5 to 15%. If it's between 5 to 15%, it will be an explosion. Anything above 15% will then create a fire. So if it is above 15%, you'll get a fire, and then it will move down into the threshold of 5 to 15%, and then you'll get an explosion. So this one was particularly between the threshold of 5 to 15%. Therefore, it was an explosion. As we flew and used our drones into those tunnels, and some of our technical experts and our officials, they went into those tunnels where it was safe to do so. We could not pick up any other indication of black scotch from a fire or so. So that part is also clear from us with regard to the particular percentages and the threshold that I just spoke about now. The delivery of this report then marks the end of the immediate response from our side and the work that we've done in the previous few days. And that will also then indicate to you what our plans will be in the short to medium term as we are moving forward. Our rough estimate at this point currently sits at around 178 million. And that is based on work that has been done, but it's preliminary work, it's preliminary designs. And we will indicate to you as we are moving closer with detailed designs, that particular amount might then increase based on the designs that we will have. So that is only preliminary to look at what it will cost us for the road, what will it cost us for any other infrastructure damages, and also to reconstruct that particular tunnel. So we are now moving into the next phase. In the interest of transparency, it is important to note that the residents of Joburg that the city has so far spent an amount close to 4 million rand in this project on professional experts, services, the cording off of the site, technology that we've used, the provision of temporary relief in a form of water tankers, temporary ablution services, and so forth. Now, the executive mayor mentioned that indeed that this particular incident, we've realized that it was not a City of Joburg incident, it was not a Breyer Street incident only, but around the world, people have now showed some level of interest in this particular incident. People are waiting out there, including academics, to see what it is that we find in terms of the reports that we will be submitting. So everybody is looking at Joburg, and that is one of the reasons why we can clearly say to you, we've appointed the best of the best teams available in this industry in order for us to be able then to express some form of alliance and an opinion on the work that they would have done. A lot of lessons that were learned following this unfortunate incident. In order to avoid future recurrence, the tunnel design will be upgraded based on current international codes for tunnels to reduce the risk or severity of these type of explosions. We will also introduce continuous gas detection and alarms and gas detectors, the sensors and monitors for all staff working in the tunnels. What will become critical as we are moving forward, you need to note that these tunnels were constructed in around 1935. At that point when it was constructed, it did not make provision for all the things that we are looking at now, including gas and so forth. So as we move forward to reconstruct and to upgrade these particular areas, we would even need to then upgrade it and to ensure that we use technology in that regard. Our tunnel's design will then be based on international relevant standards, which will include the National Fire Protection Association, NFPA 68, 69, 502, 921, and all the other relevant sections and or regulations or prescripts in this regard that focuses specifically on tunnels and explosion prevention with accidental combustible gas release in tunnels and or cavities. So the detection based on NFPA 72 standard, that will be based on South African relevant standards for SANS, specifically for water, sewer, and for road signs. The tunnel roof and side walls will be designated to withstand depressurize with deflagration vents at a 9.5% methane explosion. And these are some of the things that Johan will also touch on as we are moving forward. Suitable materials for the tunnel would be reinforced, concrete sidewalls and roofs designed for this overpressure and the release. At this stage, we remain confident that we are on the right path in our efforts to respond and recover from this incident, and will once more implore the public to bear with us and to provide us with space to do all what is necessary for the successful recovery with all the sites and services. It's also critical for you to note, as much as we are focusing on that area of Bray Street, we will also be doing the area surrounding there. And we will be having similar type of projects like this to look at gas detection and any other issues that we would have learned now in this process. And we'll also then reveal that as we are moving forward. And I think that for us is critical, because that becomes proactive, but also at the same time preventative as the city. Before I hand over to Johan to take you through on his report and the presentation, I just want to quickly address the reports which seek to suggest that the city does not have any internal capacities to deal with disasters. And I think we need to focus on this. These particular statements, we find them misguided and misinformed for the emergency that we had to deal with. During such an emergency, highly specialized technical skills are required. The additional technical support and the assistance can be leveraged from private sector, the industry, and/or can be standard practice for us. Like I've indicated, this is something that we've realized that it's at an international level. The world is waiting for us to respond to this particular gas explosion. So some of the technical skills that we had to source, we had to ensure that we take the best of the best. And we can indicate to you, we've not undermined our residents. We didn't want to shortcut them or shortchange them on the type of skills that we brought. We brought in the best of the best. We're calling on specialized knowledge and expertise demonstrates that the city's willingness and the ability to acquire the best available knowledge to efficiently respond to an emergency of this nature. Unless a city is in an area or location of regular emergency incidents, the permanent employment of those highly specialized technical skills would be warranted. So at this point, it was not warranted, but it's critical to know that the teams that we brought in only augmented what we already have. In the case of Johannesburg, infrequent occurrences of such emergency situations negates the need to do so. The existing technical skills employed in the City of Johannesburg are more than capable of conducting their duties and activities associated with their positions and skills, but may at time to time be a bit limited during the major incidents, prompting the city to acquire the best available knowledge. And that is exactly what we have done. So we've ensured that we augment what we have with the best of the best. Let me now hand over to Johan to just take you through on some of the technicalities with regard to the incident. Thank you.
Yeah, good afternoon. I'm going to show you something on a screen. I'm not sure how we're going to look at it because you're all looking in this direction. So,
You can do the presentation.
yeah.
They don't have to look at the screen. And then we can just talk to it.
Okay.
They don't have to look at it, but you...
No, I'll speak to that. I think the interesting thing is, you can go with that. It's just a table of content and explosion. You can continue with that. I think as we achieved the first investigation and stabilization, services are back. We did the analytics of exactly what happened. Next one, Niku. What we want to make you alert to is that these incidents happen all over the world. I just show a picture of where it happened in 1969 in New York, where 6 blocks were also blown up by a similar thing. It happened earlier this year in Venezuela. It happened in China. A 5-kilometer pipeline was actually exploding with methane gas. So methane gas, although it's very useful, also at low quantities is also very dangerous. So that is why it is a common occurrence, and that's why it is international interest that we learn from each other. We source from international sources who have actually worked on this before, and we are connected to that because we also do international work. And that is why our sources, the person that do the analytics for us is Dr. Antonio Cicciano, and he is working in American-based companies from South Africa, very knowledgeable guy, and we reference to the University of Stellenbosch, who have a fire department and training fire engineers. They have a number of PhDs and a number of master students in fire engineering. You have, for instance, modeled the Lebanon explosion for a reason to get people out of jail that was jailed incorrectly. So that's a level of competence we include, is international knowledge that we source and apply. And the technologies are not developed in South Africa. It is very expensive technologies, assimilation technologies we use. Can carry on. So that is the area where it happened. You can show the next one. So I already spoke to the specialists we have, and then we also have brought in some of the best equipment and laboratories at Sanna's testers. The old man with the grey hair that you see there is a forensic specialist. He took in some samples for us, and that was sent to Palindaba to analyze the content of the gas. And that's what we're looking at. Somebody who have been 40 years or 30 years in this, I think he have investigated like 2,000 or 3,000 fire investigations in his life already. So that's a level of knowledge we brought to this, and that is not the kind of expertise that you can keep in-house, because you don't staff for accidents and incidents, you staff to run your business. And that is why specialists like him and myself are handy to use us whenever there's an incident, which we don't wish for. Next one. So the overview of the investigation, the first one was stage 1. The response was good by EMS. Everyone come to site, all the people responded, all the divisions, as well as emergency services, that is the fire department, JMPD, they cordoned it off. And we went through the actions that they took in the first day. There was even a private company that also came to assist with their crew, who was operating in the fire department space, and they willingly assisted. What they have done is the right things that we have seen internationally, that's done everywhere. As part of a process we do, we always recommend corrective actions. If we see there's a smarter way, or if there's something that they could have added to it, we'd find nothing. Everything worked like we have seen in all the international incidents we investigated. Next slide. Stage 2 was then the remedial thing. That is where we then applied science and drones and investigate the sources of that and try our best to come to the root cause. In the meantime, our very capable departments start with the remedial work. The moment that we could declare the site safe, we first have to block and shut off the gas leakage of the rupture, because the slab blew into the air. A pipe running across it was actually pulled from the main pipe, from Egoli, and that was shown in the system. So the moment that we could resolve that and declare it safe, all the departments get in and they start patching it. And you can see here, there's interim stuff done where we just fix it, that we can get all the services back to the people living in the buildings. You can carry on. So the future where we're going to, that is the stage that we are on now. We're looking at the future city. What will be applied is a conceptual design of how we will solve it. We will apply the latest technology of preventing it. It means venting it, because methane go up. If it was vented, it wouldn't be able to collect and then get to a condition where it's explodable. And there will be also deflagration openings in it, and there will be a detection of gases. You can go to the next one. So the one that we ruled out, Floyd have already referred to that, so we don't have to go through that. Our investigation have clearly indicated that none of them are guilty. If I look at the Egoli gas, that was the question. I went to the control room and we went to the time sequence of the SCADA system. We could see exactly at 17:30 when the explosion happened, there was a big rupture. And then I went in the history, because I understand how SCADAs work. I've built a lot of them in my previous experience. So we went back in history and I tracked all of that. And you see that normally consumption, daily consumption, and only this peak. So we went back a week and I gathered evidence of that. What you can't pick up is what we call small leaks or pinhole leaks, if that's it. It looked like a consumption. You won't know if it's a small leak or whether I just opened 2 more stoves to use the gas. So that we can't exclude that, but they didn't contribute to a sudden quick leak or a burst pipe or anything like that. And when it happened, they immediately responded. They have 24-hour personnel and staff in the control rooms monitoring that immediately. Next slide. The emergency, and this is where the interesting part comes. That is the tunnel layout overlaying the CBD of electricity. And the interesting part is that on the left-hand side, we are at 1,724 meters. On the right-hand side, we are on 1,748. It's like 24 meters. So the watershed is right here on the top. So when you have gas anywhere from a lower position getting into the system, and there's different sources I will talk to. It can be methane gas coming from a lot of large sewers. It could be from the earth gas. I think very few people are aware of that. But the underlying structures have methane in. And the day of the explosion, we have a seismic event at 3 o'clock in the afternoon. And 3 weeks before that, we have the big seismic event. And the underlying structures is the same that they harvest gas in mines towards Sterkstorp's area, 1,900 liters per minute methane gas. So that is potentially that event like that could have percolated gas, and it will actually end up in our cavities. That's what a tunnel is, a cavity. The reason that it get up to that is as we expanded the city and grow over the years, the pipelines that were on the sidewalks are now in the side streets because we increase it from 2 lanes to 4 lanes, and then we seal it over with tar. So when there's a leak from the bottom, either from the earth or any of the pipes, it can percolate to the tunnel because it can't easily get out. So that is sort of the theory we look at and how we solve that going forward. So that is the main reason it went to the top. And then at the top area, we also at the right-hand corner there, and I'll show you some drone footage. There is a crossover of an old post office tunnel that was built in 1935, running from Jeppe Street down to the station with 3,000 bags of mail per day. And that tunnel is still there, so the electric tunnel actually dipped underneath that. And to the right-hand side is a water slot. So you have a water slot at the bottom. It's the highest point. It's the best place where your gas will actually accumulate over time. Whether it happened over 2 days or 2 months or 200 days, we don't know. It accumulated. The unfortunate thing, if it is a natural gas that comes from E. coli or something like that, I put in like a perfume, we call it an odor, then you can smell it. If it comes from the earth or it's methane that was generated by a biological source like the sewers, you won't smell it. So our people can go in there, they can work there, up to 15% they're fine. They will just get a bit tired, but nothing will happen to them. As long as they don't smoke, then they will get blast. So we don't know at what stage and how fast it accumulated. That we don't know. So that is the highest point, and that is why it accumulated there. You can go to the next slide. I think the cause that we say is methane. We confirm that also through models. I'm not going to show all of that to you. So we compared methane and LPG. We built this whole model in 3D. We run it through a supercomputer, a 3,000 cores to analyze it, of how it will disperse. Will it go up? Will it go down? How long will it stay? To make sure is it methane, or is there any other possibility of that? The confirmation is that it is methane. We are quite sure it's methane. It's nothing else. LPG would actually have gone down and won't explode in this region if it was an LPG leak. It's the normal gas that you used previously. Methane gas is going up. LPG gas is heavier than air and go down. Just go back. I think you're slightly too fast. Okay, so then what we then say that the deflagration started at the top and then run to the bottom. There's a better slide I'll show it to you. And I think the event that happened, there's 2 CCTV cameras. I think the one everyone saw with the taxis from behind. We found another one that you look from the front. And on that we have a better time frame, and we can actually see the electricity flicker, and it goes down, and then the explosion happened. So there was some event that actually triggered it. And it starts from the bottom and go to the top. And it's exactly as we modeled it, and that's what happened. Go to the next slide. And that is the cameras that we showed, the 2 of them. And it shows you the timelines on that. We could actually found evidence of when it happened. And then there you can see the taxi already like 1.5 meters in the air. I think we reduced the number of slides. The report was like 50 or 60 slides. But to give you an indication what happened is when we modeled it, the gas that you need, and that is the interesting part. I think a lot of you would relate to the incident in Benoni that a lot of people were killed. You would realize that it initially burned, and it burned for a while. And the reason for that is the gas was at 100% or 90%. Then because of that first explosion, you get a gas cloud. Now it mixes with air, and you go to the explosive range. Explosive range is if it swallowed air and it's between 5 and 15%, and then you see the Big Bang. But with that, you see first the fire, then the Big Bang. So why didn't we see a fire here? There wasn't a lot of gas here. What we have here is between 5 and 15%. So now we run the models and do the engineering and say where it was. So we look at the structure on top of it, the destruction, the concrete layer, the damage that we saw on the walls and how it was lifted. So to lift the walls on top, just to lift it slightly above the ground, would take about 1 bar to 1.5 bar pressure. What we have seen that this is more or less 9.5% methane that we had with the explosion. So it started off, and once it's contained, the nature of it, and it's well researched because there's a lot of documentation on what happened in mine explosion, where there's a lot of methane explosions. When it's contained, it starts slowly at 350 meters per second and a pressure of about 1.5 bar or 1 bar. That's why you won't see destruction in the first about 30, 40 meters where the explosion started. Then it accelerates. As it builds up pressure, it goes faster and the pressure goes up. Our models show us that it went as high as 17 bar, and that is why you will see a taxi 1.5 or 2 meters in the air, and you will see that the structure above it broken because on top was a concrete slab, but the side walls was brick, so it wasn't a strong structure. There wasn't any ventilation, and we have an interesting phenomenon in South Africa. If you leave your manholes open, the cables walk away. So now we weld them closed, but that keeps the gas in. And that is part of the problem. So if the manholes was open, there wouldn't be an incident at all. That's why we see the manholes blown off and the damage done. So as it then accelerated, the speed picks up. So you go up to about 1,700 meters per second. So what you can see in this video, it almost looks if that whole street exploded at the same time. Because it will take like 0.76 seconds from the bottom to the top to cover the 400 meters. Much faster than anybody can run. And that's the nasty thing for explosions, you can't outrun it. So we are quite confident what it was and how it happened. You can go to the next slide. I think there I actually explained the whole thing from the bottom. It seems like an electric cable fault at the bottom. We must still confirm it with the electric department. We're going through the SCADA data to see if we can confirm that. There is a small chance that maybe somebody had took a smoke in the tunnel, but then we'll still find him under the bricks when we start picking it up. So far we haven't found anybody with a match that is below. So then it actually accelerated from the top. We started deflagration, that's when it is slow. So if you catch it in your tunnel have deflagration vents, it actually will take the pressure off. It is the overpressure that caused the destruction. So then the destruction would be less. So going forward and design it, we will design the release points for it. First we will ventilate you don't capture it. But if something like that happens, you will create the release points. And it will be side vents that the people who let the cables all can't get in. So we can still keep the manholes closed. And then you get into the detonation stage, very close to the top end and the right end where you see the color change. From there, we took a dip underneath that water pocket, and it dips down under the old Telkom tunnel. And the pressure wave continued, but then because it was, we call that the blast wall, a 90-degree turn. It's like a traffic light to say go right. Then it was just the pressure wave that continued, the overpressure. So it still ran for another 150 meters, blowing off manholes, down to the post office manhole in front of the High Court. That was also welded close, so it actually blew the manhole with its cover and frame and all the bricks of it out of the pavement. And then the pressure actually reduced because there wasn't any gas left to accelerate it anymore, and then the energy faded away. So that's how far we could see that the incident went. So that is basically the storyline of how these incidents work. I think the learning point from this is also that tunnel next door to it, running from there to the bottom, we tried to get into that. I'll go to the next slide, perhaps we have left some of those ins, no, conclusion, yeah. I think we took it out because I had the 3D model showing it's the thing underneath. The question is that for methane? Is that sort of the next one that something can happen to? So we will try and find it and then ventilate it. We find a side entrance, we just could get access with post office services. because that's a mall now, the old JP post office, and we couldn't get access to that. And then a question to that is what we suggest as part of our recommendations. Go and look at all the tunnels. There are actually a number of tunnels running. From this building, there's 2 tunnels running. One running right into the center of the city that nobody knows about. It's a big secret. That's where they move gold and money and things like that in the old days, and they didn't get robbed. But the reality is a cavity and methane that may come from the earth, may come from the sewers, and you have ignition source is something that can create damage. And it should be managed and find out who's the owners of that and is it well managed. Was it a mistake? This is a perfect storm. A number of things come together. If there wasn't gas and there wasn't some fusion point there, we wouldn't have an accident at all. So it takes 3 or 4 things to happen to create this perfect storm, and that's why I have the incident. Can we prevent it? Yes. I think when in 1935 we didn't know about it. If you go back in the history of gas in Joburg started in 1830, 1890, around about there, and then it was used for street lamps. So at night they light the street lamps with and they use coal to generate gas, and then they have the central street lamps that was gas lamps. That's where gas comes from in Joburg. So it's a long history, it's a very valuable product, but they didn't know how to build tunnels at that stage and to vent it, and they didn't have NFPA. So we have all of this experience. We're not smart, we just learn from other people who had the experiences, and we learn from them. So the conclusions is basically, I think I don't want to repeat all of it. We did discuss the methane and how it exploded and how it happened. I think you can carry on. I can't remember, I don't think there's something significant additional here. It's rather preventive with ones, you can still go on, yeah. Okay, so the recommendation is the first thing is be practical, remove the rubble and see if we can see any perhaps a source that we can pinpoint where the methane came from. So far we couldn't track it down. The difficulty is it may have come from much lower at the bottom end of the tunnel because it will move upwards. So we must go and search further if you really want to know where it came from. At this stage we don't see a trace of that, and that is the problem. It comes like in spurges. And it happens in the sewer systems. When they're overloaded and full, it will sort of breathe and then it let that out. And it may also with an earthquake that breathe and let it out. So that's very difficult to find. At this stage, the measurement is very low. In the sewer line, there is methane, but a very low percentage as well, 2%. So we measure that every second day just to make sure it doesn't build up, but it's not getting out. So the recommendation is then the existing services, we put in CCTV, we've flown in a drone, we establish what needs to be done. So if you have to rebuild that section and it's a pipe that's 60 years old, perhaps we need to replace it before we actually rebuild the road. When it's in good shape, we are not going to replace it. The sewer pipes in that area is basically the old clay pipes. Some of them show a bit of cracks on top, and it's because of aging. It's nothing to do with the explosion, because the soil actually buffered it. So our recommendation is just to decide whether we replace some of those while we're busy rebuilding that area. And then I think the design we say must be based on the international standards. That's the NFPA that will tell you how to ventilate at what speeds. We have detection in that will tell you different levels, different gas. And then preventatively you can either vent, or you can put in what we put in an oxygen lowering gas. It is just a bit of nitrogen you release, and then you take the levels down and it can't explode. So if you get to close to 15%, okay, release something and then it is also safe. So there's a number of things that need to be considered. At this stage the area is safe. People can live there. It is just to get it prepared. Next slide. I think, are we done? Okay. So I think that's a general thing. I think behind it, there's a whole bunch of science. We really scratch and look at everything. I've been through every building to look at LPG cylinders that leak. We only found 2 small areas, one of 17 kilogram, and another one of 48 kilogram at 2 restaurants. The rents are running on electricity. So we really turned everything upside down to go and say if we can't get a source in the vicinity of the explosion, and sort of a block up and a block down and around. So I think we're confident it's safe. A geotechnical thing, and that's something you may also think, so I've told you I think a long time ago it's safe. And the explanation for it from geotechnical is that because it's soft soil and it's like a marshmallow, You give it a squeeze and it just sort of give away back. Because it's soft soil, it expanded slightly in the sideways with the explosion, but that absorbed the power, and that's why it was horizontal. And the top layer was not very high, so it actually released most of the power to the top, unfortunately for the taxis, but that's why there was no damage to the buildings. So the buildings, there's one canopy overhang, there's a bit of mud that must be washed off on one window that we saw there, and then there's a patch of about 300 millimeters of plaster in one basement that came down that they say wasn't there before, we're not sure. But we also have drone footage to ensure that there's no funny claims in future. So we have a snapshot. The drones are actually powerful instruments. So we know exactly how it looked the day after the thing. I'm going to show you just one short clip quickly. I'm not sure if you can start it up. You can look there of a drone that we went in. We did a 3D modeling on that.
They're always hands-on.
With that we did some of the structural analytics as well. I'm just going to run it. This was at the bottom end. So on the left-hand side, you will basically see we actually do the 3D modeling of that, but we use that to actually then build a model for the computer analytics. Is it not running? It's running in the computer, sorry, let me just switch that off. There we go. Okay, so here you can see some of the results of the explosion. All these cables before the explosion was on that cable racks on the left. On the right hand side you see the 88 kV cable that actually came down. This was the day after the explosion, so we haven't isolated all the water yet. So this is one pipe that crossed over that was broken, and we battled to close it. On top there, you actually saw the cracks. So this crack that you see here is part of the blast. And you can see the directional stripes is the direction that the blast actually went into. And therefore, this part of the structure still needs replacement. Some of that you can see here on the side wall, some cracks, and that is the impact of the explosion to the side walls. Some of the other photos, it even moved it a full brick in, and some areas it collapsed. There is just going after the entry as well. So we have flown a lot of this at all the areas, and we have mapped a 3D map of that. Very handy technology, but it allowed us within the first 2 days to actually look behind where the risk was, and with that we actually extended the demarcation. We pushed it further back. We thought that this piece of road was safe, and he said it's not safe to put traffic over it, so we actually blocked it a bit further. It was another about 37 meters. Here you can see the damage that was caused by the explosion. And here the temperature wasn't that high. In the middle of that tunnel here it would have been about 700 degrees C, but it went up to 2000 degrees Celsius where it take a turn on top. So there we actually also see evidence of scorching on the plaster because of the high temperature. So from the analytics and the specialists that we involved, we have seen many of this before. It's a very sad event, but we know what it is. We know how to deal with it. We can give you the confidence that if you repair it in a correct way, there won't be a recurrence. And I think the opportunity is perhaps we make tourist walkways of all the tunnels we discover or going to do, and then there's something positively coming out of this. But at least just go and check. There may be time bombs waiting for us.
Thank you very much, Johan.
You're welcome.
I think without further ado, let's allow colleagues if there's any questions. I know some of it might be very technical, and maybe just a point to make. The report itself would obviously have to go through the council processes. It has to be a council report by the time we can issue it out as a public report. But because of the interest in the matter, there was a view that there must be a brief to share some of the findings we have. But once the processes of council has been satisfied and the report has been shared with council, it can then become a public report for everyone to go through it and other people to review and engage with it. If there are any questions, we would like to take those now. The executive mayor and the chief. Looks like everyone understands in the session. Only Alex. Okay.
Sorry.
Alex, just yourself.
Thank you so much. I was just wondering, now that we know the potential cost and all of that, do we have a potential timeline for the street?
That's fine. Oh, Lindile?
Sorry, Slenda Nomasekane from ENC. Just to clarify how much it's going to cost and what exactly is going to be going into the redesign or the upgrades of the tunnels.
Thank you. Seems like there's no other question.
Yeah, you do.
Yes, sir.
Timothy Bernard from African News Agency. Johan, my question is to you. Your thermal imagery there shows us, or not the thermal imagery, but no, not that one.
Point cloud.
The one that shows that 90 degree. Obviously, the darker color shows where the intensity of the blast was, and then light orange lower. But that's in an easterly direction. But what prevented the blast to go down towards Bree Street? This is where the KFC is, because the road is also substantially damaged here, but way before this explosion. So
Yeah, the reason for that is, I think we carry on.
Before you do,
Sorry.
Let's hold the thought. I just want to make sure there's no other hands because there's been so few. I'm only going to allow one round and then we'll close it after this.
No, we normally warm up after one round.
No. I think let's allow Johan to respond, and then the
last
CM
question.
will take the question from Slinelo, and then if the EM wants to wrap it up, we can wrap it up afterwards. Oh, Johan, you can.
Yeah, sorry about that. I didn't pay attention. The reason for that is also in the structure. It looked exactly like the top. It make a T-junction where the explosion started, so it absorbed it. There's also a water trap that absorbed the energy of the explosion, and there was not much gas left. Because it's at the lower side going up, the gas is on the top, it's not at the bottom, so it don't propagate the explosion in that direction. Plus it is also like a T-junction, it looks like that, exactly like the top. So fortunately there was a T-junctions and a dip under the old tunnel, else it would have run another block and destroyed that as well. So I think because it was contained, it limited damage, and we were just fortunate.
Thanks, Johan. City Manager.
Thank you very much. The potential timeline for the project, let me touch with this one and answer it with that the estimated cost. I indicated that the estimated cost is around 178 million. This will include the redesign of that particular road. It's an estimate. We are not at a detailed design stage. Once we can clear the rubble and be sure exactly what it is that could have been damaged from the side of Joburg water, whether it's the water system, storm water, or even the sewer systems, we will have to do something with regard to some of the cables underneath for city power and how to block them off. But it will include a clear redesign of that area, stormwater and absolutely everything. But like I've indicated, the estimate is something that might change as we get through to detailed designs. What is critical for you to know is that one of the main stakeholders for us is also those property owners in that area. We already met with them today as well physically, where we've already agreed on an approach where they will be part of our planning as we move forward. There will be further discussions with any other stakeholders in the area, including the taxi associations and so on. That is why you'll see our Department of Transport is also with us, Department of Economic Development is with us, in order for us to zoom into those particular shop owners and look at the process after this. But critical to know is that what we now need to focus on is a proactive way as well. As much as we look at the 178 million on Breer Street, a lot of work will be done on other areas to do similar type of exercises, to become proactive and look at preventative issues so that we prevent something like this to happen. Timeline? Somebody this morning said that I hope it won't take up to 18 months. We can guarantee you it will not be 18 months. Our procurement processes in the city is a bit shorter because we do have pre-qualified bidders on our panels in the different entities. We understand the economic spin-offs and the effects that you'll have in Breer Street. So we've got a clear interest as a city to showcase what it is that we can do in a short space of time. But what is very critical, and we know that this will come at some point where others would want to use this as a football to start to focus on certain processes. Whatever it is that we're going to do, we've got emergency procurement processes in place, clear internal controls in order for us to curb any other related issues, and that will be chaired by our group's Chief Financial Officer, Mr. Tebogo Moraka, and he will be ensuring that whatever it is that we procure, one, it's market related, two, it is compliant, and that it will be ready for audit as and when we move forward. Thanks.
Number two.
Can you not ask it offline when we're done?
It will be quick. I promise.
Okay, that's the last
Sorry.
hand it seems, and then
Yes, and yeah.
There's an end,
or last
I'll
two.
speak to you.
Okay, last hand, and then we'll close it afterwards.
I forgot to ask you, where are we in the disaster process? Is that going to be granted?
Please state that.
Thanks, thanks, Mli. Yeah, I've learned that Alex is one of those, she does not forget anything that we would have said. Last week, Wednesday, I said it will take us 7 days. Today it's there. We're about to submit. We had to wait for this assessment. Already we've met with the Provincial Department of COCTA, and I can indicate to you the engagement that we had with them on Monday, and a quick indication today is that indeed they will consider our request as we're moving forward. So we are about to submit. We should be finalizing by tomorrow or so. The documents are final on my stage from my side. It's just final signatures. It was all to do with the final assessments and this modeling that we just had to go in and get that in. That forms part of the submission.
Thanks. Ian, I don't know if you'd want to make any last comments.
Yes. Thank you very much. In fact, what I needed to register, of which is a critical point at this juncture, is the fact that although we understand the importance of us having to conclude the reconstruction in the shortest space of time, I have an overarching priority that I registered during my acceptance speech, which deals in particular with the quality of service that the City of Johannesburg delivers. I'm not going to put the city manager under pressure on the basis that we want to see something happen. It needs to be a process that also, like he had alluded to earlier on, is inclusive of critical stakeholders who would then be able to advise on some of the technicalities of the environment and what we need to carefully consider in the process of us restoring the inner city. And I'm not saying this to try and get him off the hook in saying that it's going to take a long time. No, that's not what I'm doing. I am just registering the fact that it has to be at a quality that the future generations can look back on and say, in a state of a situation or a crisis, this is how the City of Johannesburg was able to use this opportunity to advance some of our priorities as this current administration, because it speaks to them. It speaks to our priorities of creating and advancing smart cities, which is a critical element that needs to be incorporated in how we are going to respond to the reconstruction of Pre-Street. It speaks to safer cities. I know that when we speak of safer cities, we consider public safety only and forget the fact that there are other elements. You know now, ne? You know now, ne? Yes. Okay. There are other elements that we need to be cognizant of in protecting the residents in the future. And I'm glad that our technical team is considering that very closely, and they are providing solutions on how we can prevent this. These tunnels are 40 years old. I was not even born. And the effect is happening in 2023. So how are we going to protect the next generation who are not born today from encountering the same challenges and situations is what you need to speak to in the response. The inner city rejuvenation is another priority of this administration. So we are not just limiting this to finding a quick solution that is going to restore, but we need to make it better than it was. And that's one of the outcomes of engagements with stakeholders. How are we then contributing through a dialogue with the stakeholders to increase the value of their properties in the City of Johannesburg so their investment lasts for a longer period of time or is is increased over a period of time, and it does not degenerate like some of our dilapidating buildings and infrastructure. How do we incorporate additional plans that we as a city have to ensure that this is the beginning of a strategic priority that we have as the government of local unity? So it's the priority of the inner city has become top of the agenda across the board, across all departments and municipal entities. So we are doing not just what we can, but we are putting our best foot forward to set the tone of what the inner city is going to look like in the future. CM, and I'm putting that on you. I must deliver, Chief.
Will be a smart city.
There we go. Thank you very much.
Thank you very much, colleagues. That brings us to the end.